Welcome. Today we're going to be doing a custom build inspired by everyday objects. The plan is to follow up with additional videos to show some of the parametric modeling for the 3D printed parts and to go over the simulation results. So we're going to skip over those for today, but tune in again in the future for that content. So now what we're going to do is we're going to remove the bottom from our Quaker Oats body tube here, and then we're going to sand down the bottom, make that smooth. We 3D printed some transition sections. The first one was a little bit off, so then I printed just the base, and that looked good. So then we reprinted the entire transition. It's a really snug fit on the bottom of the tube, but it's a pretty thin transition. So it took a couple tries to get right there. Now we're just going to mark these body tubes. The body tubes we're using for this build are, of course, the Quaker Oats can, but the actual rocket tubes are the thin wall, low and medium power tubes from Apogee Components. We'll give a link down below. For this rocket, we wanted rear ejection, so we're going to make a motor mount that's going to come entirely apart from the main rocket on ejection and come down under its own parachute while deploying the main chute for the rocket. What that means for the motor mount is that we're going to have one big centering ring at the end acting as a thrust plate, and then we'll have two more just to keep those parachutes from being able to snag. We also like to use these screw-on motor retainers. We'll put a link for those down below as well. That's someone else's design. Now we're going to move on, and we're going to make sure that the larger centering rings to adjust from the inner body tube to the actual aeroframe are the right size. We're just going to slide them in there. It's a pretty good snug fit. We have enough room to seat the transition and check the dimensions there for the box fin. So that all looks pretty good. We're going to move on now to creating the baffle. This would go in the motor mount itself, as we'll see. It's just a 3 half moon baffle. We've used these with pretty good success previously. Now that we see that those dimensions look about right, we're going to move on to gluing the centering ring. So we're just going to pick one side and start applying fillets of glue to each of the centering rings. The same here on the motor mount. And we're going to install the eye bolt for the recovery system. Now we're going to go ahead and glue in the motor retainer. We're going to put some wood glue on the spar of that baffle just to get a good base. Then we're going to flip these over, and we're going to apply fillets of glue to the other side of all the centering rings. Now, given that we do want to use a baffle and we're going for rear ejection here, there's more than your normal amount of heat and gas that can be trapped there. So we are going to mix up some JB Weld just to kind of give us a little fireproofing and heat tolerance there on the hot side of each of these components. So that would be each of the 3 half moons for the baffle as well as the spar, and a nice coat on the one side of the bulkhead where all the gas is going to be redirected. And when I have it mixed up and I have some extra, I like to apply it as well to the motor retainers. Those are just printed out of PLA plastic. I've run them both ways, with and without the JB Weld. It doesn't seem to make a difference so far, but just a little extra confidence there. So now I'm applying a liberal amount of glue just to get that inner tube firmly seated into the air shell there. We'll leave it on the nose just so that all that glue can run down and we get a stronger fillet there. Now what we're going to do is we're going to come back and measure for the launch lugs. This is going to come off of a 1010 rail, so we're just going to drill into the centering ring on the bottom there and go ahead and screw in a 1010 rail button. These rail buttons were also from Apogee Components. Now we're just going to apply another fillet of glue there on both sides of that centering ring just to make sure we have a nice strong connection. Then we're going to move to the forward rail button and make sure that we put that down far enough so that it doesn't interfere with the shoulder of our nose cone. Then we're going to move on to installing the transition section. For this rocket, it's almost a boat tail. It's just immediately before the fins. So we're going to get that there. Then go ahead and use cyanoacrylate glue to get that in place once we have it seated. I have a little bit of trouble seating it, so I put a little bit of a bevel there. Again, it was a very tight tolerance by the time we got it off the printer. So we'll put the super glue there and slide it in, and then we'll put a little bit of super glue on the front too, just to make sure. Again, that shouldn't be a real structural component, so I feel comfortable enough using the the super glue. Time will tell. Now, I am a little concerned that the shock cord might overly abrade or zipper the end of the body tube there. So I just wanted to stiffen it a little bit without adding dimension. So I did use some sanding sealer in there just to give a little extra strength to the rim of that body tube there. Now we're going to use E6000 here to glue on this box fin. We're just going to go around and make sure that we have a nice solid fillet of glue on all the surfaces there. And again, in a future video, we're going to go over the parametric modeling for creating this for the 3D printer. Now we're going to move on to the recovery system. So we measure off several body lengths worth of Kevlar string there to act as the shock cord. My kids like to run around with the rockets while the parachutes are out, and they tend to tangle. I found that putting a swivel can make unknotting those just a little bit easier there. So here I am installing a swivel on this. So now I just feed the shock cord up through the bulkhead. One of the things I decided to do here, given the narrow diameter on the bottom and how far down it is, I figured if I ever needed to change the recovery system out, it'd be easier to go from the top end. So I actually have the eye bolt facing the depressurized top end there. So the cord passes through the bulkhead and then is secured. Another thing that always makes me paranoid coming from a climbing mountaineering background is to have nothing but static line in your system. So I always like to add a dynamic element if I can. So what I'm going to do here is I'm actually just going to tie a rubber band in line with that Kevlar string. So hopefully that'll spread the time out for the load and really reduce the overall spike in force that's experienced by the components. At this point, we need to update the simulation for as built. So we're getting some initial measurements here for the weight. Going to add all the components that we're planning on using. The way we've designed the nose cone is actually two parabolics so that most of the weight can be adjusted just by adjusting the infill density on the 3D printer to put that weight as far forward as possible as well. So this is going to let us know how much weight we need to move forward to shift our center of gravity and make sure we have a nice, safe, stable flight. Now, one thing we haven't tried before is what we're doing now. We took out of just a Nerf football whistler. Occasionally where it launches, we hear a real sort of pleasing whistle as a rocket moves through the air. And given that we were having a bomb here and it was going to come down under parachute nice and dramatically, we thought it might add something if we were able to add a sound effect. We'll see how that pans out. So now we're just going to finish attaching the rest of the recovery hardware. We're going to attach the small parachute to the motor tube, and we're going to tie on the larger parachute to the main rocket. Now, as we discussed earlier, we really want most of the weight that we can with the nose cone to be as far forward as possible. So we have sort of two parabolics here to make most of the volume on the front of that, the very tip of that nose cone. So as you can see here, that makes it behave sort of like a weeble wobble. One of the design challenges of these shorter, fat rockets is getting that center of gravity moved forward enough. With the initial simulations, we were going to be real marginal as to whether or not we could achieve that 5-to-1 thrust to weight ratio on the lower thrust black powder motors. So we just gave up on that. So now we're going to go ahead and make a nice heavy nose cone, move that forward, have a nice stable flight, hopefully. For the first ground test, we didn't secure the nose cone, so we're just going to shim it here a little bit, take some of that tolerance out with some masking tape. And with that, we're ready for our first ground test, and spoiler alert, it was a little energetic. So we'll see you next time. Thank you.